Hello, this is a video presentation for subject Geotechnics 2, BFC 34402 Section 1. We are from Group 7. The members are myself, Muhammad Farhan, Muhammad Razlan, Tengku Ahmad Faiz, On Kai Sheng, and Ahmad Fuad. And our topic is about the deep pit soil, problematic soil. So I'll start with the introduction. So for the introduction, Earth has natural resources that is important for the living thing on Earth. Not only air, sunlight, and also water, but there is one more natural resources, which is soil. And soil is very important to all of the living organisms on Earth, as it is the basic need for the plants. And there are also many types of soil, as each of them is very different, such as loam soil, pit soil, sandy soil, and silty soil. So next is the problematic soil, which means that for this kind of soil, there needs many development, construction, or even agricultural activities cannot be done on this problematic soil. So in Malaysia, there are many types of problematic soil, such as low sulfatic acid soil, pit soil from a mining soil, brick soil, and many more. And for problematic soil, usually it needs some maintenance costs and some improvement before that soil can be used for any purposes. So pit soil, which is our topic, is considered as the most dominant or the biggest type of soil. And the pit soil is composed of flakes and pieces of plant residue, leaves, twigs, and even large trees, which have not been yet fully decomposed. Sometimes it is also found because lack of oxygen prevent decomposition. And it also has a high content of organic material and usually can be found at the moist soil area. So the characteristic of the pit soil are dark in color, high acidity, slow rate of decomposition, high number of carbons, low water porosity, and it heats up quickly. So next is the objective. There are three objectives, which is to identify the properties, to study and suggest the solution, and next is the introduction of the design principle in ground improvement. So next is the importance of soil in construction. Soil has many uses, even starting for the base for the foundation and construction material until complete of one construction. Also in terms of geotechnical properties such as specific gravity, shear strength, permeability, and many more. For an engineer, there can be no mistake in making the decision of all things in construction, as a building can collapse if there are mistakes in process of construction. So soil is very important as it acts as the base of every construction. So the soil should withstand the load of the building without any failure. And besides as the base, soil also used in making the building material such as bricks and cement, and many more. Also, the soil physical properties and chemical properties is important and needs to be analyzed before the construction. And analysis and discussion are important for every construction process to prevent any accident happen in future. So, lack of soil knowledge will lead to catastrophic construction failures.
Hello Doctor, hello everyone. I'm Okashan AF10263. Today I would like to present about case study part. There are three case study about failures of building construction on the peak soil highlighted here. There are case study on bridge failure, case study on construction of the housing project, and case study on construction of road. In each case, more details will be explained more further for better understanding. For case study on bridge failure, there was a case study about the construction of a 13.5 kilometer single carriageway connecting the Egan Bridge to a planned university site. The site was located at Sibu Sarawak, which is located at East Malaysia. The soft soils of maximum 30 meter thick were found below the pit layer of 5 meter thick. They were treated with prefabricated vertical drains in order to decrease post-construction settlements to meet the design requirements. After site investigation and soil characterization tests, it has been successfully built by using hydraulically placed sand fill for the replacement of the underlying fibrous pit. The installation of settlement press was carried out in order to supervise the sand layer PVD system settlements. Based on the information, it stated that the obvious increase in settlement rate was achieved when PVD was installed. Field instrumentation result cross-checked with Asoka observational method to measure settlements was successfully carried out in order to give a good understanding of ground treatment of fibrous peat and soft soil. This figure show that PVD and also the settlement plates which were installed. The first figure show that installation of PVD after sand fill achieved the existing ground level. The second figure show that condition of settlement plates while the site was flooded. For the case study on construction of the housing project, there was an investigation about a failure of the structural building on soft soil. The discussion about a case history of a housing unit in Shah Alam, which is located at Selangor, was carried out. Based on the information, the irregular settlement of the foundation structure happened because of the foundation settlement. This issue occurred due to lack of consultant supervision during construction. Furthermore, there was no issue on the design and structural plan that can cause the failure. Therefore, it was recommended that supervision of the settlement is compulsory for the troubled building. Suitable consultant supervision is compulsory to be executed on all construction projects in the future. For the case study on construction of road, there was a case study about a project which was located at Sibu, Sarawak. The project is that the Sungai Bidut access road built by hydraulic sand fill based on total replacement and charging method. Based on 36-month post-construction observational studies, the overall serviceability limit for the route based on function and performance basis on the settlement seems to be satisfactory. However, the serious lateral movement and collapse of road embankment at the RC covered were undergone by one section of the road embankment along km 12 plus 100 to km 12 plus 400 because the overdraining of groundwater from the surrounding oil palm plantation development occurred. The two figures show that the situation happened there. Based on the case study, the important lesson is to avoid using of peat soil as the retention bump material to retain the hydraulic sandfill embankment because the fibrous peat soils have high permeability and cannot act as clay liner to avoid seepage issue within the circumstance of critical hydraulic gradient resulting from blockage or insufficient discharge capacity of balancing cover. The another lesson learned is the serviceability limit for the route that is well designed within the design criteria. Okay, the table is the geotechnical analysis on consolidation settlement of road embankment during and post construction. Okay, I think that's all for me. I would like to pass my presentation to my teammate. Thank you.
Hi, hello everyone. I will present my part is application for ground improvement. What is ground improvement? Ground improvement is the modification of existing site foundation soil to provide better performance under design or operational loading conditions. Ground improvement is technique used to increase link for new project to allow utilization of site with poor subsurface condition. Uh, Ground improvement techniques are used to improve the following problem from the soil such increase in soil load bearing capacity by making it denser, reduction in the soil settlement, reducing a large amount of pore water pressure to avoid soil liquefaction, avoiding shrinkage and expansion. Normally, there are three ground improvement techniques adopted. First is vibrocompaction, ground freezing, and lastly is soil nailing. For vibrocompaction, this method are suitable for port construction and marine project. This method also most economical and sustainable. Next is ground freezing. Ground freezing used to provide regional groundwater barriers and mining operation for gold and other minerals. And lastly is soil nailing. This method can use on either natural or excavated slope, commonly used to remedial measure to stabilize the embankment. So that's all from my part, and next we proceed to chemical improvement.
Assalamualaikum. My name is Tengku Ahmad Faiz bin Tengku Muhammad Ghazali. Matrix number DF180030. Today I will present about my part about the ground improvement techniques of chemical modification techniques. The first point is the chemical stabilization. This chemical stabilization is the form of soil stabilizations that involve using chemical agents to start reaction within the soil and modify its geotechnical properties. The soil stabilization is the treatment of soils to improve the texture, increase strength, increase the CBR value, and reduce the shrink swell characteristic. The soil adjustment is the additional of active additive such as the lime and cement to modify the index of property of the soils. The next one is chemical modification techniques. The ground quality is improved by the techniques by introducing the various compounds into the soils to alleviate the problems. There are many building options for pits and organic soils to improve this method. The first point for the chemical modifications technique is the additional of lime. By the addition of the lime, it reduces the optimal water content of the pit soil while increasing the overall dry unit weight of dry density. The lime is also commonly used to stabilize weak fly ash, reducing settling and improving the bearing performance. The hydrated limes was used as a pit soil additive to enhance some of the soil's engineering properties. The lime soils reaction can be divided into two categories, which is short term and long term. The next point is the additional of the cement. This is the most popular stabilization method for the soil treatment, as the soil pore water comes into the contact with the cement. The cements hydrate quickly with the main hydrations, reducing hydrated calcium silicates and hydrated lime. The addition of the cements lower the liquid limit of the soil. And then by according to the previous report, by adding chemical admixture such as cement and lime to tropical soils, it will enhance their engineering property. And then the final point is the cement stabilization is provide strong comprehensive strength and it's preferred for the soil.
Assalamualaikum and hi. My name is Ahmad Fuad bin Tajul Arifin. My metric number is AF180143. So now I will talk to you guys about our conclusion. The characteristic of the soil need to be observed as the soil are very problematic in construction and geotechnical. There's a lot of perspective that need to look at before considering ground improvement in pit soil. By recognizing case studies papers that are closely relevant to the issues of problematic soil, then analysis from the past is very important to assess whether or not the land enhancement applied can be overcome because of problematic soil. The creation of the issue soil is more valuable when the land is wet with excessive rainfall and low permeability. It is possible to split soil problems into two groups, which is physical and chemical soil issues. The soil is recognized as a problem soil in the building industry due to its low bulk density, high compressibility, and high initial water content. For the engineer, constructing the structure as a road and then building on it is improper, usually subjected to the base pavement, which is the compacted. This form of failure become poor at the edge of the roadway. This factor will decrease the efficiency of working structure.